You will be able to express numbers in scientific notation and switch back and forth between scientific and standard notation. For the first example, I'm going to convert this number, 147.2, into scientific notation. First thing I'm going to do is locate the decimal point. Decimal point is right there. Then I'm going to rewrite the number and place the decimal point between the first two significant figures, like that. And then, the last step, I'm going to count how many steps it takes for me to catch up to the original decimal point. So I'll go 1, 2. And since it took me 2 steps, then I'm going to multiply it times 10 to the second power. Since it took me 2 steps to the right. And this is my answer in scientific notation. So say I had a different kind of number, 1472, and say this is a really large number. Okay, I want to write this in scientific notation. First step, I want to locate the decimal point. Where is it? I don't know where it is. But any number is automatically going to have, if you can't find a decimal point, it's going to have 1 at the end anyway, but it's kind of invisible. So there it is, there's our decimal point. And then, what we gotta do next, write down our significant figures, 1472, those are the important numbers. And we're gonna take our decimal point and put it in between the 1 and the 4. And then we're going to see how many steps it takes to catch up to the original decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1.472 times 10 to the 9th power. Now what about this example? Say I had 0.001472. I'm going to put that in scientific notation. Well, I know my decimal point is here, okay? Now, what I got to do next is I want to write down my significant figures, 1472, and then I'm going to put my decimal point in between the 1 and 4, so I have 1.472, that's my new decimal point. And then I'm going to count how many steps it takes for me to reach the original decimal point. So this time I have to go backwards. 1, 2, 3. I went backwards 3, which is going to make my exponent negative. So it's 1.472 times 10 to the negative 3, because I went backwards. And that's how you do example 3. Now for my next example, say I had a number already in scientific notation and I wanted to write it all the way out. Well, what I'm going to do is this is my decimal point right there. Always keep a track of where the decimal point is going to be. So that's the decimal point. I'm going to rewrite my number, 4219, and you see my exponent is 3. And we know that the exponent is positive whenever we move to the right. So I'm going to take my decimal point, I'm going to put it here, and I'm going to move it to the right by 3. 1, 2, 3. And now my new decimal point is there. I'm going to fill in the rest of my zeros like that. And this is my new number written in standard form. Now what about this example? This time I have 421.9 times 10 to the negative 3. And I want to write this out in standard form. So what I do, of course, I know where my decimal point is, as always, because you always need to keep track of that little decimal point. And I'm going to go, 4219. And I'm going to take my decimal point and I'm going to move it 3 to the left. Because when you move to the left, when it's negative. So I'm going to go 1, 2, 3. That's where my new decimal point is going to be. And therefore, my new answer is going to be 0.4219.